Very good morning to all. Today, first of all, I would like to congratulate all of you on this occasion of Dashera. I wish you a very happy and prosperous Dashera for all of you with your families. Thank you very much, Professor Dr. Breja Saab, who has accepted our request on this day, auspicious day when we are celebrating Dashera. Today we have very important and interesting topic related with operational excellence in the midst of technological interventions and digital transformation. As we are all aware, with the development of this industrial evolution, at this now we are working in this under Industry 4, R&D 4. That is what how the industries are working automation, how the automation is working, how we are actually developing the tools and the system by which the things are moving by their own. This is all we will discuss, we will learn from Professor Bereja. Professor Dr. Bereja is professor at the North Cape University, Gurgaon, and teaches strategy, operations, and supply chain management to MBA and PhD students. Earlier, he was joint director at National Council for Cement and Building Materials, Ballabgarh, and head of quality management standards and collaboration services, training services, and seminar and information services. He has developed 42 reference materials, got BND approval from National Physical Laboratory India, coordinated nearly 60 PT schemes, and was the first in the country to get enable accreditation for PT services for NCCBM. He has over 100 research publications and presentations and 14 book chapters to his credit, and won 6 Best Chapter Awards at national seminars. Earlier, he has spoken about quality assurance and 17025 from this platform. Today, we are requesting him to talk about accreditation of to talk about this operational excellence in the midst of technological interventions and digital transformations. Thank you very much, sir. Now, I'd like to request Professor Breza to kindly enlighten us with his vast knowledge and experience to all our participants. Sir, after this presentation, we will share your presentation with all the participants, and video will also be uploaded on the website as well as on our YouTube channel. Over to you, sir, please. Sir, your mic is off, sir. Mute.
Yeah, sorry. Good morning, everyone, and happy Dashera to one and all. Today is a very auspicious day, and thank you, Mr. Ashutosh ji, a good friend of mine, for such an energetic introduction and a nice introduction. So the topic today is about the Industry 4.0, and also I'll be talking about a little bit in the end about Industry 5.0 and how the industries are coping up with the changes in the midst of the technological intervention. We are seeing technology all around us. It is not that everybody has joined the bandwagon of Industry 4.0. So the industries are on different levels of a technological curve. So the challenges they are facing, that also we'll discuss, but also the exciting news, whatever the exciting news is, and what is beneficial for the consumers. We all are consumers. That also I'll be discussing. And let's see that I think my screen is visible now.
Yes, sir, very well.
Okay, so we'll start. So the topic is operational excellence in the midst of technological intervention and digital transformation. These are the buzzwords nowadays we hear. Okay, so sometimes we wonder how it is related to us. But we know that we are all ordering the services nowadays through Blinkit and all, taking the benefit of Zomato and riding this thing cars also and all that, this Ola taxi and Uber taxi and all. And the experience has increased during the last 4 years since the COVID times. I think the pace of the industrial revolution in the terms of the technological changes has increased in unprecedented manner because of this COVID outbreak that all we have experienced. I think you will all agree with this also. Had it not been for this, this has been a boon also, and we know that always there changes are there, inventions are there, discoveries are there in the midst of the challenges. And whenever we have the challenges to meet, and we all know that necessity is the mother of invention, isn't it? So because of this, I think we are facing all these challenges. And if we talk about the bad part, it is okay. Let us. The bad part is there. So these two things, I think, the way the universe is working and performing, the God's this thing hand is always there. So these things are happening. These we can say these are the two sides of the same coin. Okay, so we'll be facing the challenges. There will be this thing, bad side also, but upside also. So the objective and the agenda today is that digital transformation is an happening process for the organizations. Now we are seeing that, and technology is used is an imperative, even by small organizations, and we have to meet these challenges. See, this is the basic supply chain model. So I was in Japan. I was a JICA scholar also. I went for this thing training on standardization and total quality control. So that was in 1998. So that time I experienced the use of the ATM. That was a very rugged ATM at that time. I experienced the use of the ATM for drawing the money in Tokyo. That was an exciting experience. That time we didn't have the shared taxis and all that. And mobile phone also was just being introduced at that time, 1998. And I was the first one from my organization to use the laptop in an organization. We didn't have the laptops at that time. We had the desktops only, and that very few people had the desktops even. So there I used not only the desktop but the laptop also. So that way I was fortunate. So I joined this technological race, you can say, but being in 40s, it is always challenging, you know. Even if you learn the driving at the age of 40, you won't be as savvy, tech savvy and driving savvy as the young people. So these are the challenges, and we have an now we'll be having aging population. We have the best working age population also in the this thing world that we are going to have. We have very good young population. So we will see that the phases of change are there, and everybody is not on the same actually growth curve. So we are having this is the model of the basic supply chain where we have where the factory is connected on the one end with the suppliers, and then when the factory supplies the goods they go to the warehouses and the distribution centers, and from there the end customers are served. So this is the basic model which we as a consumer we know that, and if we are having a production factory then also we know that, and if we are talking about the services instead of the factory we will say that there is a production unit, like in the case of the cinema movie. There the producers are there and the production unit is there, so they gather all the resources and then they produce a movie and then it is distributed. So there is no warehouse you can say there, but the distribution part is also there. And when we, as a consumer or as customer, we go to the theater and we watch the movie. So the infrastructure and facilities, all these things are required. There is role of publication, there is role of promotion, advertising and all that. And then we have to do the raw material control, process control. And here is where lies the importance of the operational excellence, because the operations have to be managed, right? So what is operational excellence? Now, operational excellence is the primary tool, okay, and to achieve best in class streamlined operations, and the focus is on just in time. I think you might have heard this word just in time, which comes from the Toyota production system, and Toyota production system means which has been propagated, which has been actually developed by distinct Toyota corporation for manufacture of automobiles. Now, this operational excellence is it enables organizations to achieve excellence along entire value chain. And actually, value chain management is the keyword for operations manager. So we just don't say the supply chain. We talk about the supply chain as a value chain, because value is added at each step from the suppliers and to the customers. The value is added. That is why there is and the money is involved. And that is why the price of the finished good is more than the cost of the raw materials and all that. So OPEX is about managing quality, cost, delivery, and through quality improvement approaches. Now there are various approaches. We know total quality control. Earlier there was in 1960s, then it became total quality management and waste management lean actually approach. This is very much popular nowadays, and Six Sigma approach, okay, which developed from Motorola. Lean approach has developed again from the Japanese distinct Toyota production system. So these approaches focus on customer, waste reduction, process optimization, and problem solving. There are 7 QC tools for problem solving. There are new 7 QC tools, again, old 7 QC tools and new 7 QC tools for this thing problem solving and continuous improvement. This is actually the Toyota philosophy. It is not just a production system. That whole Toyota system is actually based on a philosophy. And Toyota took the world by storm during the 60s actually, 1960s and 70s. Okay, and they hosted the Japan hosted the Olympics also in 1964. And after Second World War, it was very actually challenging for the Japan to come up to the world standards, but they did. So there are Toyota principles are there, the partnerships are there. So it is called Toyota Way and producing happiness for all. This is their mission. Unless we have a mission in life, we cannot proceed. Toyota is having a mission, producing happiness for all, and vision is creating mobility for all. So, like we, the other day, this thing, our great Ratan Tata, Mr. Ratan Tata, he passed away. So we can say that we have an Indian system also, Indian way of production and Indian way of this thing. We have the Indian philosophy, and Ratan Tata, he stood best for this. So people have if you talk of the Indian quality, I think in future Ratan Tata will be carrying the flag after his death also. Now that yes, Indian brand is what it was about. Ratan Tata or the Tata Industries or Tata Corporation, it is a big conglomerate. So like Toyota, we can talk about Tata also. So vision of the Toyota is creating mobility for all. And these are two pillars of Toyota. Jidoka, first is the Jidoka. Jidoka means the automation with the human touch. This is just Japanese word. So where human wisdom is added actually to the automation. And I'll be telling you in the last slides that when we talk about human wisdom here in Jidoka, Toyota is talking about it. Whether this thing Toyota very early imagined even Industry 5.0 also. Because human wisdom means that when an abnormality occurs, such as a machine or equipment, then there is a system that it will stop automatically without human intervention also. So this is called Jidoka. So Industry 4 5.0 is also leading us to that destination only. Then there is just in time. Just in time means making only what is needed when it is needed and in the amount it is needed. So we fulfill the orders from customers as quickly as possible. And this Jidoka and just in time, this thing philosophies and the system is being copied by other industries also all over the world. Okay. So total quality management. Now I'll be telling you about lean also. What is total quality management? It is about the commitment. First, the commitment to excel actually and meet customer expectations. Then planning is required there, and the support of lots of tools and techniques is there, and education and training, that is the main thing. Then teamwork and working together. So TQM is also about working together, and Industry 5.0 is also about working together. So TQM, then measuring, actually the strong we need a measurement system, and we have to focus on problem solving and continuous improvement and sustaining the gains whatever we make about improvement. And the cycle rotates like this, so we have a cycle of continual improvement as the foundation for total quality management. And lean is about waste management. Actually there are 8 kinds of waste which have been identified. And then these are, first is the defects, whatever the defects are there in the production or in the products. And when I say the product doesn't mean only the physical goods. I will say about the services also. Like we are having here the seminar, here the workshop, if there is some technical snag is there or some interruption is there, that will lead to the service quality defects. That is also a waste. So we have to make the system in such a way that it is defect free. And there is a system for like Pokayoke also, that we plan that there won't be any defects also. Then defects are there. Then waiting time defect is, you will see the long queues in front of the malls, at the airport and the railway station. These are all waste actually. Then transportation waste, unnecessary transportation, waste of motion in the factory also, when you are moving here and there from one machine to second machine and the machines are not installed properly, that is waste of motion. Then overproduction also, because there will be overstocking, lot of inventories. Then non-utilized skills of the people, the talent, that is also a waste. We have the industries, the organizations, all kinds of organizations have to pay attention to this. Then waste of inventory. Then over processing also, extra processing also. So when we say just in time, means the what is produced in what quantity as per the requirement of the customer, it should be produced in the right quantity. There should not be extra processing also. Sometimes we say that we have to delight the customer. Okay, we have to delight the customer to what degree? There should not be over processing also, extra processing also, because that is going to cost money to the organization. So these are the 8 ways of the lean. Lean means as we know, lean means thin, slim, you can say. So lean management. Okay, like we have the mobile phones, Apple phone, you can say it is very thin and slim and lightweight and all, and it performs very well also. Then Six Sigma. Six Sigma is also a very popular approach which developed through Motorola Corporation. and was implemented at General Electric also. There are many success stories that companies employed this Six Sigma tool for getting the benefits of operational excellence and actually saving millions of dollars and billions of dollars. But there are failure stories also, because the companies didn't think that controlling the process through this defined, measure, analyze, improve, and control was not only about reduction of the process variation, but also maintaining their focus on the centricity of the process also. So you see this is the concept actually in Six Sigma process variation. If we have we reduce the standard deviation, okay, if our central tendency or the average is also lying in the middle, then it is okay within the upper and lower specification limits, and also within the company limits. Then we'll be having only 3.4 ppm defects. Otherwise, what will happen if the process shift and if the central tendency or the average is not maintained? We will say our products are still passing, they are going to the boundary line, but what is happening? We are not having the consistency in the process. So when Six Sigma maintains the consistency in the process and the standard deviation also is low, and coefficient of variation as compared with other processes also is low, then we can reap the benefits of Six Sigma. And it also uses a lot of tools like Pareto chart is there, fishbone diagram is there, test of hypothesis, correlation and regression, design of experiments. All these are for reducing the process variation. So we have to pay attention to not only reduction of process variation, but also maintaining the consistency of the process. So these are the core elements of the operational excellence which we are talking about. It is very useful for the metrology organizations, for the laboratories, for the manufacturing industry, for the process industry, continuous production industry like steel industry, cement industry, sugar industry, thermal power process industry, and also for the services also. Any kind of services organizations like the airline services are there, or the railway services are there everywhere. So the five elements which has been proposed by McKinsey is that there are the five elements like purpose. The first is the purpose. What is the purpose of the organization? So that is about creating a common cause with a strategy to achieve it, like the mission of the organization or the basic purpose. Then the principles and behaviors are necessary to achieve the strategic vision and establish a culture of trust, respect, and innovation. So this culture of trust is very important. Otherwise, we will fail. That we should remember. We may try to bring many new approaches, Six Sigma, this thing, problem solving tools and all that, unless the people are ready to accept. So there is a lot of importance of training and education also. People have to be trained, and there has to be cultural change. Then management systems, these will develop the leaders and build competencies. Then technical systems are required, which will eliminate the waste and deliver value. Then the role of technology is there. Technology will augment human capabilities to continuously improve. And in today's this thing interaction, we are focusing on the technology also, and mainly the because of the technological intervention. However, these other elements of the system are being affected, and we have to meet the challenges. So this is we are going to discuss what is the role of technology in improving the systems and meeting the needs of the consumers. See that from a third industrial revolution, we have moved to the fourth industrial revolution. So technological intervention means we talk about the fourth industrial revolution. What it is about smart manufacturing. Today we talk about the smart cities, smartphones, smart manufacturing, and all that, and intelligent factories. So the Industry 4.0 aims at to achieve enhance productivity, efficiency, and flexibility while enabling more intelligent decision making and customization in manufacturing and supply chain operations. So what is the focus in Industry 4.0? It is on IoT and big data. And it is also synonymous with smart manufacturing, which is the realization of the digital transformation of the field. So, and delivering real-time decision making, enhance productivity, flexibility, and agility to revolutionize the way companies manufacture, improve, and distribute their products. So focus on IoT, smart manufacturing, decision making, and intelligent factories. So if you take the cement industry example, I saw the Robo Lab at Ultratech Cement in 2003 in South. Then I have been to other cement plants also, like Wonder Cement. I have seen very good this thing, and I have used those pictures also in my this thing research papers also and conference presentations. So this is I'm just going you to show how the cement industry now works 24/7 and 365 days. Operations are occurring in cement plant because they have the robotic legs where the all the operations, many of the advanced laboratories, they are having operations of sample collection, testing, all are performed by the even sample collection from the mines and the other areas also by robotic this thing interventions, and we get the better quality control because of the use of the robots. So cement industry is using. And then the steel industry, steel industry also is using the robots and all. And automation and robotics are useful where the humans are not capable of doing the things, or they cannot go to the areas where it is difficult for the humans to go. So the robot should be used for that manner, and not, I also feel that it is unnecessary to use the robots and all that unless it is for the glamour and all that, attracting the customer, robots for services and all. For like in the restaurants, there is no need of using the robots in the services like in the restaurant. Rather, we should have the humans performing the functions like robots, and but giving the best of service with the human touch. Human touch is required in the restaurant, not automation. Of course, in production and distribution in the restaurant also it is required. Of course, like in the burger also, burger industry also is this thing having a semi-automatic systems and all. So that is okay for production. Then automobile industry, you will see if you visit any site of the automobile industry, any company, sedan is there, Toyota is there, or Hyundai is there, or here in our country, Maruti Suzuki and all these, they are using a lot of automation and robotics. So what is the actually the situation today? The situation today is that the country or the industries are in a situation of flux. Okay, because I said that all the industries are not equally on the same actually level. So to ensure future growth and even business survival, the OPEX or the operational excellence approach is currently undergoing change, because we are having the interventions, technological interventions. So what are the changes? Just that also, and the challenges we are going to see that. So realizing the importance of IR 4.0 and trying to take advantage of the new developments and trends, companies, particularly in the automotive sector, are using IR4 tools. Like how use of this thing artificial intelligence, it is helping understand customer requirements better, designing products with generative AI like chat gpt we are having. So generative AI is helping in designing better products with the help of algorithms. It is being used for product designing also. So we know the Japanese approach, quality function deployment, which is used for understanding the customer requirements, benchmarking, and having the product characteristics meeting the customer requirements, and producing and quality control using SPC all on one sheet. We are having complete plan. So that QFD approach is used for product designing, and this also gets the technological help in designing the products for synergistic utilization. So you can say that when you use the technology and AI, etc., with the technological help and quality function deployment, that is like 1 plus 1 is equal to 11. That is called synergy. So we get the multiplier benefit. So the way services are delivered and how far companies offer a seamless customer experience, that is becoming a primary future differentiators for the companies. So customers want this thing seamless customer experience, be it any sector of the economy. Whether it is construction sector, even everybody wants that we should have seamless this thing customer experience. So excellence in operations and adaptation to the new pace of change is becoming a basic requirement for all thriving businesses. And this is where technology is becoming the great enabler. Technology is not actually the leader, it is an enabler actually, and we have to know that. And in the early part of the century or in the late 90s, when the companies were struggling with the implementation of the computational this thing system, use of computers in the system, people were struggling, and we saw that how the people were saying that no, 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 computers are not for us, we are this thing. But now the things have changed. Everybody is now becoming, has to become tech savvy. We have to survive. If we say that English we will not learn like we used to have in our country, let us talk our country also. So if we think that we will not learn the English, we will be left behind. So we don't have to, this is a global world, we have to be open. And when we talk about diversity, diversity means not only about the regions and the language, it is about the languages also. We have to accept the language, whatever sells. See, whatever, like we say that whatever is displayed, that only sells. So whatever the behavior we are having, we should be proud of all our languages, and also we have to adapt to the English also, because it has become, whether we accept it or not, it is an international language. And we have to celebrate our diversity and our Hindi language also, and all other regional languages also. Even now, because we learn the German also, French also. I also learned also French. I know the French also, and I have learned Bengali also. I was in Calcutta, so we should be learning all the languages. And technology is just an enabler. It is a facilitator. We cannot say, and again, language should not be a this thing barrier also. So we have to accept the change. We have to accept the change, and we have to adapt to all the changes. So this is the how the things are changing. So we have a situation we can compare in this picture. This is a Deloitte diagram. So traditional versus digital supply chain. I showed you that this thing. representation of the supply chain, which was connected from suppliers to the factory, to the warehouse, to the distribution center, to the customer. Please recall that. And here we are showing the comparison. This is the traditional supply chain on the left, where we are having the development and planning, sourcing, making, delivering, and support. So for the 3D printing, also the format is shown. So we have the cognitive planning, then quality sensing. We have to sense what are the sensing quality requirements, then develop, plan, source, make, and deliver, and support. After sales support also is required. Now, in the digital supply networks, what happens? It is not just cognitive planning, there is synchronized planning. So you will see that interaction is there between all the distinct components, all the parts of the system. So synchronized planning, and in the center we are having the digital growth. So this is the new technological supply chain, or the digital supply chain. You can say digital core is at the center. Then we have the synchronized planning, connected customer and aftermarket. Today we have the concept of connected cars, that also we'll be discussing. So connected customer and aftermarket, then smart factory, intelligent supply, digital development, and dynamic fulfillment is also there. And all this is happening with the help of the technological system. So digital core is at the center. So we can very well imagine that we are, whether we accept it or not, we are surrounded by technology. We are in the midst of the technology, and we have to understand how this operational excellence, the traditional model, is undergoing the change. Right? I think it is clear. Okay. So there was this, I will give the reference of the European Union study also, which was conducted in that 2020. They said digitalization is heavily impacting organizations and all distinct aspects of the supply chain. So technologies such as IoT, IT, uh, cloud IT, blockchain, smart sensors, automation, robotization, these all are becoming more easily available, and thus a key success factor in satisfying growing customer expectations. So the EU study has identified four mega trends which are going to
आपको खुल
radically
गया कौन
change
सी
the
बस
current supply chain environment.
बंद
This
करो जब पीले हरे सब लिया मुझे मिल रहा है
okay.
वैसे भी क्लास ले लिया
Please mute yourself. So
थैंक
the
यू
study has identified four mega trends, which will the EU study said that will radically change the current supply chain environment. These are linear value chains, then accelerated sensorification in cloud IT, robotic process automation, Industry 4.0. So Industry 4.0 will lead to new manufacturing paradigm, they said in 2020. Linear value chains will become highly connected ecosystems, so networks covering operational boundaries. So that is what we have seen in the previous figure representation of the digital network which I have shown. Then they said accelerated sensorification and cloud IT. These will amplify data and real-time transparency. Please mute yourself. Please mute yourself. Okay. Mr. Ashutosh, please mute yourself. So accelerated sensorification and cloud IT will amplify data and real-time transparency. Then RPA, robotic process automation, collaborative robots, and Karakuri. What is Karakuri? This is again a Japanese term, I think, which will be new to many of you. So Karakuri means the lean methodology involving simple mechanical material handling devices that rely on gravity. So this also is going to be a mega trend and industry 4.0, which is going to lead to new manufacturing paradigm. So EU study had said that digitalization is going to heavily impact the organization, and that these four trends will be visible, and this is really happening. Then we had, so what, see, the things are changing so fast. We have the concept of software defined, it is not defined, sorry, defined vehicle, I'll correct it, software defined vehicle, SDV. So many car drivers, what it is, you see, many car drivers expect their vehicles to be fully integrated into their digital lives. So new connectivity, automation, personalization features, these are going to become increasingly implemented with the software in the future. So while in the past the customer experience of a car was primarily defined by hardware, we all experience that hardware has to be this thing. We know that when we used to drive the Ambassador, and when Maruti came, it was a light car. Ambassador was heavy, so the customer's focus was on hardware. How you see the things have been changing gradually, and we are not even knowing. We can recall and learn from the past. So software now is now taking on a much important role. So this trend of software massively shaping the customer experience, and in some cases even the specification of the hardware, is referred to as a software defined vehicle. So today vehicle is in its best condition when it leaves the factory. But what is going to happen in the future? Do you know that software can be continuously optimized also within the limits of the hardware? This means that the vehicle can even improve after leaving the factory. So can you this thing imagine the same, understand the same thing as it is happening in the this thing smartphone also? We can optimize the system. We are updating the iOS and system and all that. The company are continuously updating the software in our computers also. We can update the software. Similarly, in the vehicles also, it is going to happen that after the this thing production during the service life also, the customer this thing will be experiencing optimization of the software for a better service and a better customer experience. So software defined vehicles will be there. And this is the picture. You can see that software defined vehicle, it is about the consolidated hardware and software, which is upgradable, connected, data driven and flexible also. This is called software defined vehicle. So these are the trends in the industry, and there are valuable lessons to learn from the automation industry, automobile industry, because automobile industry always is leading in terms of the technology also, in terms of quality also, in terms of process excellence, operational excellence, and now in the midst of the digital transformation also. So so much is happening that we wonder whether Toyota imagined and implemented Jidoka in the Toyota production system, which is automation with a human touch, where human wisdom is added to automation. Did it really imagine that? Okay, IR5. So early they imagine, because what is industry division 5, that also I'll show you. You see that Toyota is this thing implementing global architecture, okay, and smart this thing. Two-way, the future is here. You will see that well-built cars, TNG. This TNG means the working together consistently from planning and purchasing. Then smart manufacturing, which is called monozukuri. This is another word, smart monozukuri manufacturing, collaboration at production sites, including suppliers. TNG means working together consistently from planning and purchasing through production. Then smart sharing, the idea of grouping development and enhance basic and product performance, well-built cars. So we have this picture, the integrated TNGA cycle, which is called, and TNGA means Toyota New Global Architecture. So they are having Toyota New Global Architecture and Smart Monozukuri. So Toyota is implementing structural innovation across global car making business to make ever better cars through Toyota New Global Architecture. So this is a program actually starting from of structural innovation, starting from changing the basic architecture of vehicles. So with integrated product development, Toyota anticipates a rapid development and in three areas basically: basic driving performance, like moving, turning, and stopping. And so in doing so, we hope to continue providing cars that our customers cherish. This is what Toyota says. So the idea of the TNG cycle underlines the improved basic and product performance of well-built cars while incorporating smart sharing that considers total optimization and promotes smart monozukuri in collaboration with suppliers and production sites. Okay. So this is the picture. You can see that well-built cars, smart manufacturing, smart sharing, and at the center is working together. So reinvestment by streamlining and ever better cars to customers. So here in our country also, Maruti Suzuki, they are focusing on people technology. What do they say about people technology? They say that it is about through technological interventions. Effort is to make a true noticeable difference that can enhance the lives of people from all over the country. So the focus, what is the focus? It is focus on ensuring a positive, tangible difference in the lives of the people who choose to put their trust in us. So it says, Maruti Suzuki people say that we work hard to make people's lives easy today, and we work even harder to make the world greener tomorrow with a concerted focus on sustainable mobility. We call it people technology because it's centered on people's this thing experience and making a difference in the lives of the people. Like the Toyota says, ensuring happiness for all. It is not only we say that customer delight and all, the happiness for all, including the society. When you drive the car, the people around also, they will also be satisfied and they will also be feeling happy. There will no problem to the people around also. Lesser gas emissions, lesser pollution, and better experience. So for the society as a whole. So, but the issues of concern are there in all this technological distinct race. First is the data privacy. Because we are having connected vehicles, so vehicles communicate with other systems and devices such as smartphones and roads and other infrastructure. There are a lot of sensors are there. You must have explained now when you are driving when you sit in the car and you start it, it will not start unless you shut the door. And if you are not wearing the seat belt, a beep will go, which will warn you that you are not wearing the seat belt. So much of sensor, so many sensors are there, and your customer behavior, actually your driving behavior also is being sensed and recorded for improving the product And also this all is also being recorded for the insurance policy also. So you are not sitting in the car just like that. It is a smartphone. Your car is a smartphone on the move. It is a smartphone vehicle actually, you can say, and everything is being recorded and sensed. So connected vehicles, they communicate with other systems and devices such as smartphones, roads, and other infrastructure, and sensors are there which collect the data on vehicle performance and driver preference and behavior. So lots of personal data is there, and that data flows back in the system, and analytics is the use of analytics is there. So actually what should happen, that data should be protected, that should be encrypted, that should be there, and industry people, they know that it is not currently encrypted. So the issues of data privacy are there. So when we are driving the car, we there, like in the use of the mobile phones, we should be careful in searching and all that. Immediately we get the this thing feelers that we have to buy this thing, that thing, everything. We are not it is not a closed system, it is an open system. We Nobody's lives are private nowadays. So this is the issue of concern while driving the car also, when we drive the connected vehicles and we are coming to that age. Now let us talk about metrology also. Unless we talk about metrology, the discussion will not be complete. So what is PTB Germany's approach to digitalization in the metrology? Our NMI, like Dr. Sanjay Yadav last time make the presentation. So there also the digitalization is happening, and PTB Germany is, what is that PTB Germany's approach? So they are saying there are four components. First is a digital transformation of the metrological services which is happening. Then metrology for simulations and virtual measurements, this also is happening. And lot of this is happening in the healthcare sector also, even for measurements and all, conducting the operations and all with the use of the digitalization and robotics. So here also they say digital transfer metrological services, simulation and virtual measurements, then metrology in the analysis of high dimensional data, and metrology of communication systems for digitalizations. So they talk about the digitalization metrology in this manner, and they say that there are three pillars actually. For Federal Institute of Metrology Matters strategy, what is the strategy? About it is about the three pillars. Say that the first pillar is about the innovative measurement system, and second is about the services, digital metrological services, and the third pillar is about the dynamic R&D and interdisciplinary framework. So we'll discuss this one by one. So what is the first pillar? First pillar is about the innovative measurement system. The PTV Germany says it says that where decentralized measurement instruments encompassing one sensor and decentralized modules like multiple sensors, example measuring sensor networks. Then the second is the measuring systems including AI modules that might evolve over time. So digital twins, depending measurement system like including AI/ML based modules and or surrogate models used as part of measuring instruments. Then the second pillar is about the digital metrological services, and it is depicted here also. Metrological services consist of service. First is the service, then the second is the process, and third is the procedure. So metrological services, they say that in the second pillar, that currently the metrological service can be deconstructed as shown in the figure. So they have three main layers: service, process, and procedures. So both service and process layers are very institution dependent, that we know. Okay, service and process. Since most laboratories embedded in existing work environments, example NMIs, depend on general tools and platforms for the creation, planning, and billing of the services. So these are institution built service and processes. So you see that service, it is about the contracting, signing the contract and invoicing. Process includes request plus planning, and then the test and calibration, execution, measurements, and all, and certification. And third is about the procedures, mean the setup, measuring the DUT, evaluation, providing the results. So this is about the second pillar, methodological service over time. And the third pillar, they say about digitalization in the metrology, it is based on the principles of the ontology of knowledge. Okay, the metas or digitalization strategy includes a third pillar, which is dynamic R plus D R&D interdisciplinary framework. So this can be of five components. Data means the measurement results, scientific publications. We are talking about the R&D actually. Then information, the techniques, knowledge, which are the know-hows and the expertise, methodology fields, and the content means the feasibility reports and demonstrator, etc. So these are the three pillars of the digitalization in the metrology, and this has been understood and presented by the PTB Germany in this system. You can say this is their approach to digitalization in metrology. So we are talking about the automotive sector, we are talking about the process industry, we are talking about the metrology, and we are talking about the customer experience also in today's times. So what are the new digital phenomena on the customer front? So new phenomena are there too. We are summing up like smart sensors, cloud IT, automation, robotization, blockchain. These are all disrupting the businesses and the way operations are managed. Now there are applications for delivery and grocery delivery application. These are raising customer expectations sky high. We expect that if we order some listing products through Blinkit, they promise in 9 minutes. Earlier, you see, 20 years back, the Pizza Hut and all that, they started the revolution by saying the pizza will be delivered in 10 minutes. Otherwise, it will be free. Blinkit says less than 10 minutes, 9 minutes for delivery and good. So this is happening. The challenge is that they have to identify with the help of the algorithms the route, the best route, the least congested route, the shortest route for distributing or for delivering the products or the food products or whatever. And then the customers, what the customers demand? Customers today demand agile and flexible delivery of the services from anywhere to anywhere. I am sitting, says in Gurgaon. From there, I can book the car for my family. They are sitting in same in Delhi in some other region of the NCR, and they have to be. They need the car to be booked, and they have to travel from one part to the another part, and I am sitting at another end. So this is customers today are demanding. It is not that I have to book the car from my this thing or cab from my home only. So this is what the requirements are there of the customer. Then digitalization, this is transforming supply chains and seamless customer experience. This has become the norm. So these are the digital age phenomena on the customer front also. Ultimately, the services and the products are produced and distributed for the customer. Unless there is a customer, there won't be production, there won't be any industry. So in the case of automobiles, today everyone talks about smartphones, smart buildings, smart cities. So what customers want from automobiles? The other day I attended a conference, and one of the this thing manufacturing industry very senior person said that customers, I think that customers today demand smartphone on the wheels, connected vehicle. They can perform all the functions while sitting on the car. They can play the music, they can play, connect to the people, and can play, even if they can play the games and all that, and their software is also upgradable. So what companies have to do now? Understand the market, create the features, and bring them fast in the market. Use the Gen AI in design and aesthetics by algorithms. Means this is already being done also, as I discussed in the previous slides. Then accelerating R&D, use of new materials, computations, right battery chemistry. What is battery chemistry? This refers to the chemical reactions that take place in the battery to convert chemical energy into electrical energy. So battery chemistry is also required, and enrich the experience of the vehicles. Customers start with search. You see that when you have to buy a car, you first start with searching. That also you will do Google search. I don't think there is any customer, even in the villages also, if they have to purchase a product, if they are having a smartphone, they will first search. Okay, there is a concept of showrooming also. First you search on the mobile and you go and buy the product, or you order the product through this mobile phone itself, or you physically visit. And there is a concept of showrooming where you visit a showroom, and while standing in the showroom you search your mobile through mobile phone, what is the price available on Amazon or whatever. So what are the prices and what are the features you can compare. So that is called showrooming, when you visit the showroom and also compare the product features and the prices through Google search or whatever the search. So the focus is on accelerating R&D, new material use, computations, and right battery chemistry. And they have to enrich the experience of vehicles. So customers start with search. So simulation also for producing autonomous vehicles also. This is also happening in the case of automobile industry. So we are moving from industry 4.0. So it is said that industry 5.0 also are now from 4.0 to 5.0, because it is said industry 5.0 also has started already. So how it is going to, let us see, peep into the future also. So while for many companies industry 4.0 is still the next thing, okay, but the things are again changing. So they should focus on what, or the trend also. So the industry 4.0 reflects the fourth industrial revolution, which triggered and enabled by developments in IT. So what are the key elements which we have already seen? These include automation, robotization, big data, analytics, smart systems, virtualization, AI, machine learning, and Internet of Things. So while companies and whole industry are still in the middle of this fourth revolution, as underlined by machine learning and IoT, so still in the middle of the fourth revolution, the next revolution is already well on its way, which is Industry 5.0. And what is Industry 5.0? How it is going to change our lives? It is relatively a new one. So according to, again, I'll quote the European Union Industries Listing Survey study. So European Union says the Industry 5.0, it provides a vision of industry that aims beyond efficiency and productivity. So this is how we have to see that how the operational excellence is being affected. The concepts of operational excellence with Lean, Six Sigma, TQM, etc. are being affected through Industry 5 4.0 to Industry 5.0 also. So this, and it actually 5.0 aims beyond efficiency and productivity as the sole goals and reinforces the role and contributions of industry to society. It places the well-being of the worker at the center of the production process and uses new technologies to provide prosperity beyond jobs and growth while respecting the production limits of the planet. So we know about the Sustainable Development Goals of UN, 17 Sustainable Development Goals, and also the whole world actually, and they are focusing now that how to save the planet. So the Industry 4 5.0 is about working together, new technologies to provide prosperity, and while respecting the production limits of the planet. Otherwise, because just the other day I studied that India has actually, you should be delighted to know that India's food habits actually, now these have been ranked number one, the best in the world, particularly the promotion of the millet, etc. Okay, so these are the best in the world. And of US and European, if what are the food habits are there of those countries, they say if these continue till 2050 in the same manner, European American food habits, it is going to cost heavily to the earth. We'll be needing 1 to 7 more earths to sustain the civilization. So the role of Industry 5.0 is going to be very important in the future if we have to save the planet. So the while the Industry 4.0 approach in this, so 5.0 complements the Industry 4.0 approach by specifically putting research and innovation at the center of the transition to a sustainable, human-centric and resilient European industry. They say this European industry says, and this is applicable to the whole of the world. So as scientists and engineers and professionals, we have to realize this thing, that there has to be a sustainable, human-centric and resilient industry. So this is about working together. Just one picture I am showing. What is Industry 5.0? Working with the machines and saving the planet, actually working together. And what we have seen in the last 3 decades, let us sum it up. So we have seen that the changes are taking place and OPEX tools are widely used in the manufacturing sectors, operational excellence in the companies, company operations division. We know waste, we have seen the 8 tools of this 8 kinds of waste, lean management tools are there. So waste, or muda, which is called Japanese word, this waste elimination processes and applying Lean Six Sigma tools for problem solving, they boost efficiency, quality and cost effectiveness. Other functions including R&D, sales, marketing, administration also use lean tools, but use of Six Sigma is limited in these functions actually. So there is fragmented application of OPEX. Fragmented application of OPEX is a roadblock. So what is the challenge to us now? It is the challenges that we have to integrate the Lean Six Sigma into the culture of the organization and use the tools in other processes also, and make use of the technology also in today's technological era for reaching our this thing, company goals and the mission and realizing the mission of the organization. So OPEX has to be extended beyond the shop floor to all value chain functions and supply chain players and take value chain excellence measures initiatives. So what are the learnings actually? The learnings are that process excellence is a key requirement for repeat orders and seamless customer experience in today's competitive world. But by combining the power of technology with that of OPEX, organizations can balance never before seen pace of technological change. There is spoiled demand side also is there. This also has to be balanced. And what is to be balanced? The need for first time right products also, flawless operations, customer relationships, business sustainability. All these can be balanced. The needs of the organization, the aims of the organization, these can be balanced by combining the power of technology and the operational excellence tools. So this is all I want to say. And in the end, I acknowledge my sincere thanks to Ministry of Consumer Affairs, Legal Metrology Division, Department of Consumer Affairs, Ministry of Consumer Affairs, Food and Public Distribution, Government of India, They have given me an opportunity to give my views on this important subject, the challenges we are facing as technocrats, as bureaucrats, as engineers, professionals, scientists. So to present my insight into the subject, because subject is very wide. I'm not an expert. We all learn from each other. So I have just shared my this thing views and my insight, what insight I have got. So, and also I acknowledge reference to the publication and internet resources which have been cited during the presentation. So thank you very much. Thank you, Mr. Agarwal, for giving me the opportunity, and thank you,
Thank you
Government of
very much,
India.
sir.
I hope you have enjoyed the presentation and it will be useful.
Thank you. Thank you very much, sir,
Thank you, sir.
this learning and very important topic, how the industries are working together and how we have to improve our industries. Thank you very much, sir. Certainly we will share this presentation with all the participants, as well as this video will also be uploaded on our all websites. Thank you very much, sir. Thank you all. Sir,
Thank you,
we would
sir.
like to take few photos.
Yeah,
Atulji,
I'll stop the presentation, stop sharing.
please, sir. Please. Atulji.
Ashutosh sir, hello.
Atulji, kindly take few photographs, please.
Yes sir. Sir, एक बार yes sir.
With this, I would like to thank all the participants, our honorable speaker, Professor Breja. Thank you very much, sir. Thank you all.